We are thrilled to take the opportunity to introduce you to our solutions, enabling 40 digital contexts for digital twins for infrastructure assets. So the agenda for this presentation, we're going to speak a bit about what is a digital twin. I think that's a question of interest. And then we're going to move to what this means to create, to manage, analyze, and share a 40 digital contexts to serve as the basis for a digital twin. We're going to speak about Bentley solutions covering all those 4 steps in the creation and management of this digital context. We're going to speak about use cases, and we're going to open the discussion to Q&As. So let's start with what is a digital twin. It's a digital representation of a physical asset, its processes, its systems, as well as the engineering information that allows to understand and model its performance. It can continuously be updated, and I would say it must be continuously updated to be used as a single source of truth from multiple sources, including sensors, live sensors, IoT, continuous surveying and mapping, and that will be used to represent its near real-time status, so that when you look at the digital twin, when you manipulate it, you see almost what's happening in the real life, and you can make decisions based on what you see on the screen without going on site to check facts. So it's really something that users utilize to predict what's happening and optimize performance on their actual assets. Moving forward with what is a 40 digital context. The 40 digital context is, as a short definition, the total of all the information you're gathering in the field and you can use to represent your digital twin. That's a digital model you're creating from multiple sources. It may be represented through reality meshes, through point clouds, through terrain models, but also imagery, GIS sources. Everything is contributing to representing what reality is looking like so that you can visualize it and manipulate it in 3D and 4D, meaning that you can capture 3D digital context over time and look at how this is changing and evolving over time. So this is what we call the 40 digital context. The 40 digital context is a foundation of a digital twin. A digital twin must include a 40 digital context so that you can make proper decisions. So we're going to speak today about how you may be embracing the 40 digital context through the different steps. We're going to speak about how to capture the data, how to convert this captured data into a 3D model that's scalable and reliable and representing the right level of resolution and precision that you expect from something you need to make decision on. We're going to speak about how to analyze the data, how to extract valuable information out of this captured data and model. How are you going to be sharing this with your stakeholders and collaborating with them in a better way and easy way using cloud and browsers and applications. And at the same time, we're going to speak about how you're going to be managing this huge amount of data, collecting data on a city-scale project, collecting data on an entire asset. We're talking about terabytes of data, sometimes petabytes of data. How do you manage this? How do you manage the original captured data and everything you're extracting out of this in the form of 3D models, 4D models, and feature extracted? So we're going to move to the first step, the capture. How do you capture data? It really depends on what you want to achieve. You're going to be capturing point clouds, you're going to be capturing photos, you're going to be capturing 360-degree panoramas, you're going to be using drones, you're going to be using laser scanning devices, mobile mapping systems, and even sometimes smartphones. The purpose of that is really to capture reality, and then you need to turn this reality into something you can visualize, stream, that's scalable. So we have several formats at Bentley that we are supporting. We can generate reality meshes. We can generate point clouds. We have entire solutions, as you'll see during this presentation, to manage all those together, including as well 360-degree panoramic images and oblique imagery you're capturing as well. So the real interest of that is to offer you a complete all-in-one experience where you're seeing everything you've been capturing in the right context and easily understand and extract value out of it. So that's for the capture part. And when you've been capturing this, then you need to manage this huge amount of data, as we were saying, and I will pass it on to you, Lama, to explain that.
Thanks, Pascal. So indeed, one of the crucial steps that we also provide in our solution of reality modeling is to manage and maintain and overview all the data that you have collected or captured or somewhere as your source of truth, all your resources that you have, your point cloud data, your imagery data, your orthophotos, your terrain models. As we said, the digital context or the 4D digital context it's a sum of data which is captured along the time, but as well is available in different formats. And what we see today is that the size of this data and the variety of these resources is extreme. I mean, it goes up to terabytes, up to petabytes of data. So you need to have a proper workflow and solution where you can bring in all that data. You need to be able to track, to label, to have an overview, keep an eye, and at the same time being able to process the data to bring it to the next step. Because you want to provide that, of course, to people and to colleagues who can use it. They need to use it in their on-premise or desktop solutions, or they need to use it online. So that managed part in our 4D reality modeling solution is really to keep an eye, keep track on all the variety of data, bring it in one single system, being able then to provide it for the next step. And one of those next steps can be to analyze the data. If you capture data at the speed of using drones, using mobile mappers, using backpacks, that means that you have a huge amount of data which is captured every day, in every time, at every change in your reality. At that point in time, you also need to be able, of course, to update your assets at the same speed. So you need to have solutions where you do not do anymore some manual work, but you need to have smart, intelligent ways to extract all your features and update your assets. And within our solution, we have different modules and products that we offer based on artificial intelligence to detect fully automated, of course, based on machine learning techniques, but as well based on the detection where we start from the LiDAR data that you have, and you can use, of course, that LiDAR data to detect over a large scale all your assets or update all those assets. So different tools here to, in a much smarter way, analyze and extract and update your assets that you can get from your 4D digital context. And another part which is essential in our reality modeling solution is that this data which you capture, which you manage, it just cannot be only for the experts. You need to make sure, of course, that reality mesh that you have captured or have processed, and all those 360 pictures, that every user, every colleague within your company can benefit from that data. So you need to find a solution, a platform that you can bring that data without sending disks, because we are talking about terabytes of data. You don't want to send disks anymore or copy data. You want to find an easy way, and that's what we have available, to bring that data into, let's say, an Esri workflow or a Quantum Jazz workflow or a MicroStation workflow, or maybe kind of a geoportal that you're using, that everyone can just connect to the data, see the data, use the data for his job that he needs to do. So let's step now to some use cases, because it's of course interesting to see those different steps: capture, manage, analyze, share, which is the all-in-one solution that we provide with Bentley, and that we can cover with our tools that we have. But let's have a look at some use cases that makes clear why this solution is so unique and why this solution is really something you can use to maintain and build up your digital twin. Pascal?
Thanks, Loma. So just a first use case, the city of Helsinki. It was captured over almost 400 square kilometers from the air, and we'll see later that we also had data from the street level. But we were able to generate first 40 digital context at the scale of a city. This means the entire city representation, all the buildings, the vegetation, the streets. The system is removing moving cars, moving pedestrians automatically. It's capturing the roof structure, the rooftops. It's capturing everything you need to better understand what your city is made of. And that's the first step to turning a city into a digital city. Because the next step would be to have your utilities, your networks. You want to have your IoT connected. You want to understand how to plan for the future. You want to integrate your future projects. You want to see different architectural programs so that you can pick the one that fits better for the future. You want to engage citizens. You want to share. You want to expose this to citizens. So the 4D digital context here is really used at the scale of urban areas to understand how the city is functioning, and at the same time make the right decisions on how to plan for a better future. Because cities would be hosting more and more inhabitants over time. We're expected to be 70% of the world population living in cities by 2050. So everybody would be converging for jobs and would be converging for a better life in large cities, and those cities have to evolve for that. Another thing that the city of Helsinki did, and that's more on the analytics in this case, they simulated the sea raising, sea level raising, and inundations and floodings that this is creating throughout the city. And they also made very funny things like having boats sailing down the city, which is probably and hopefully never happening. But when we look at this, that's based on physics. It's considering the dikes in the different levels on the ground and the building blocking water and this kind of thing. So we have used as well other solutions at Bentley for simulating floating, and this is a rendering results of that simulation. So that's the city of Helsinki. There's many cities in the world that are using this technology. And also combining this with other type of data where we can, for instance, capture data with a mobile mapping system down the street and then combine this together into one single representation of the city. So you see this in this video where it's on the left-hand side, that's combining street-level imagery and point cloud and aerial imagery, so images acquired by an airplane flying over the city. And on the right-hand side, you just see the airborne imagery. And of course, aerial images don't capture properly a good resolution on the ground, and so the ground is like melted and so on. But on the left-hand side, you see another level in the representation of a 4D digital context for a city, because that's enabling a different type of use. It's better for land use simulation. It's better for virtual reality and augmented reality. If you superimpose this with a network, for instance, you can imagine what's possible. So that was a use case on Helsinki, and give it back to you, Loma, for the region of Flanders.
Yeah, well, you all saw now a quite impressive reality mesh that was built. A huge amount of data. I want to use and show you here a complete other example. It's also on on a scale of not a city, but in this case a region, so a country-wide project. It's the region of Flanders in Belgium. And I want to stress and I want to emphasize here the amount of data. We saw it in a reality mesh, but here we see it in some numbers. The project that was done, and I'll move to an introduction movie that they have, that our contractor, our customer has created. So the topic or the goal of this project was to collect 64,000 kilometers of roads. And they're using this kind of systems, mobile mapping systems, so that exist of a 360 camera, scanners, IMU, GPS, everything is on board. It's like a Google Street View, but then of course on your own decision, and also including all the LiDAR data. And the total country has to be mapped. It was already done in 2008, has to be redone right now, and there's a new one upcoming already. So you can imagine it's an enormous amount of data that needs to be captured, but then also need to be brought online so that every employee of the government can access that data, use the data immediately after that the data has been captured. So you have a continuous update of this information. And that's what makes, of course, the Bentley solution so unique, is that we can take into account that 4D aspect to make sure that if your user needs to measure something, needs to extract some data, that he can do it on the latest data. And to do that, I want to a little bit show you what is the process behind. So, of course, you're having your mobile mappers, which are driving around. They finish the day. They come into the office. They have a disk of 2 terabytes of data each. And then you need to align that on what you see here, your aerial LiDAR data, your orthophoto, your reference system. It all needs to fit properly in that reference system. And there it starts with working with tools who can manage that data, who can see, and here you see the different, let's say this is one small municipality covered by different cars, so every color is standing for a certain type of car who collected part of the city. You need to make sure that all this data is aligned on top of each other. You also need to make sure that it's aligned on your aerial LiDAR data set or your orthophoto, so you need to make sure that it fits perfectly to your other digital context data. So you have the tools here in our solutions to see whether ground control points, you can use them to georeference your point cloud, your image, bring them on top of each other. And making sure that all the information that comes from those systems and were created, that you really get an overview of all that data and that you can manage that. But then you want to update and you want to bring that data to your users. So in this use case, once the city was finished, the contractor was bringing that into the system and sharing that data online together with all the other cities that were at a certain status. So then every employee could open just a link. They connected to that using username and password. They could type in their address that they want to look for, search on that, maybe do some inspection, maybe place some annotations, maybe do a measurement. So I'm going back to that city right here. I can not only see the 360 picture, but I can also see the point cloud or the reality mesh or the aerial LiDAR data. So everything is shared here together, and users can benefit from that and use that to check and see that. So it's a nice use case to present where starting from a continuous update of reality data, you need to bring that into the system, manage that, maintain that, making sure that at the final end your users can every day benefit, of course, from your digital context that you're capturing, and that is what the Bentley solution makes unique. Pascal?
Thanks, Tom. A very nice example. So we've been showing you a lot of city-scale projects from the air, from the ground, from both. And the 4D digital context is not just for cities, and it's used for large assets management, like for these power stations, as the Siemens power station that we've been reconstructing from the air, from the ground, from outdoor, from indoor, using drone imagery, point clouds, ground images captured with a DSLR working down in the building. And this is the kind of representation you get in the end. This is a kind of detailed uh, 3D model, digital context you can create automatically. So there's no human intervention that's fully coming out of the system. It's not perfect. Sometimes the system is confused with blurred images whatsoever, but altogether that looks pretty realistic, and you get this in matter of hours, and you immediately can plug this with your um, information database, PNID. You can use machine learning to detect objects automatically, and that's where the analysis is starting as well. You can recognize objects in photos, and the system is creating bounding boxes around objects. At the same time, this type of representation can be used for collaboration. So you can invite stakeholders, and those stakeholders can contribute. They can virtually analyze, visually inspect the assets by navigating the 3D model through in a browser or in an app without going on site necessarily. So that's saving a lot of on-site visits. In those days with COVID and so on, it's something that our users have been appreciating a lot. When we look at the logs for people using our cloud solutions, it's been increasing quite drastically in those few last months. So that's where you see that we can create bounding boxes around key assets. You can click on those assets. You can create information, description, and assign tasks to people and create annotations in 3D. So this is also this is highlighting the machine learning and automatic classification of a 3D model made out of photos in this case. As I was saying, this is detecting the objects in the photos. Because those photos are looking at objects from different directions, we can create bounding boxes. You see the level of precision. You can read things on the pipes, and the system is automatically creating an inventory. How many pumps do I have in my system? How many valves do I have? How many gauges for temperature, for pressure? And that's made automatically in your system, creating another layer that's creating more value on top of the 4D digital context. Another way to use these capabilities from machine learning is to detect not objects in this case, but cracks, defects on a structure. Cracks on the concrete structure, for instance, on the bridge. The system is taught to detect those cracks in the photos and automatically detect those. There's a way as well to paint those defects to teach the system how to recognize what a crack is, and the system is automatically vectorizing those cracks as well and creating a DGN file out of this so that you can keep track of those over time as a 4D digital context for defects and asset performance management.
Yeah, and of course, one way is the machine learning techniques that we have within the solution based on artificial intelligence. It's to update. I mean, the whole idea is, of course, that you can much faster update your assets and make sure that you're on the same speed as you collect your data. And another technique that is also part of our solution, it's then more on instead of based on detecting on the image via machine learning and artificial intelligence, is using the rich point cloud which is behind. So within Bentley solution, you can, we call it a semi-automated way, but it looks like automated. But the operators still need to say, okay, hey, I want to have, for instance, in this case, this ridge. I want to have this curve. And by clicking on that curve, it uses the shape of the point clouds and creates, in a semi-automated way, complete polylines of, in this case, 170 meters. And this can run, and therefore it's of course important that you can import your whole project and that you can do that and update that information, and any kind of difference and information you can get. For instance, here the difference between the pavement and the grass can be get in a very fast way to push that to your line work to update your assets, adding attributes, and in that way, for instance, in a telco project where you need to get all the cables or you need to have the clearance under a cable, you can just click on that, you can see, you can put it in your database, and you can use all those assets, which is also part, of course, of your 4D digital context. It's the whole set of information of reality modeling and all your features. But you see that in our Bentley solution, we have a very smooth way of adding those assets. So for instance, here, typical question, you need to inventory all those trees, but you can click on a tree, you get the height of the tree, the position, the trunk diameter, the crown diameter, and this is all pushed to your database. So in that way, you get a result much faster as an update of your information that you can use to do some change detection or analysis on what you have there available. And next to that, you can do semi-automated detection on LiDAR. You can also do a full automated process there that you can combine at the same time with your AI on your imagery. And this is just to give you an example. It's detecting all kind of pole structures in your database. It's just a sample data, a small set, but you need to optimize, of course, parameters. So it's a learning technique, and what is included in the software is that you can, if you detect here now a set of poles, you can click on one which was not detected, and the software will give you back a return to say, hey, this is missing. This is a missing part. So you can change, update your parameters, do it again, make sure that your set of parameters is completely okay, and then you run it over your entire project. But we all know that 100% accuracy or 100% result, it's hard to get. So quite often you have a QA/QC analysis, and that also is part of the workflow. I mean, you can go over all the results, check the attributes, add attributes. Operators can do that. That's a way of collaboration and making sure, of course, that it's a real project and not just a demo project, and with real results that you can use in your project. So that's about the let's say it was a little bit focusing on that analyze part of artificial intelligence on the imagery and the automated detection on LiDAR data. Here I want to present a use case where we go into the fiber to the home project. Why? Because this gives a very nice example of starting from the bunch of reality data that you have, all your meshes, your point clouds, your imagery that you brought together, how you now can work together, how you can make sure that people on the field, as well as people doing certain designing algorithms, together with people who needs to check the assets, that you all can work together using the same 4D digital context. So what we see here is a typical city. We can have the mesh, we can have the point cloud, we can have the 360 pictures. Maybe you also have some drone pictures. So you can put your layout. And this is now in a web browser, so something that people can use on the field, checking on their mobile device or their tablet, or maybe checking in the office. But of course, you can understand that in some cases, and this was for this use case, it's a fiber to the home. So what is the final goal is to generate the fiber network that we can put underground. And for that, of course, we need a reality. And while in the past, every time you need to send someone to the field, in this case, it was a software which was developed in QuantumJS. The whole process of the construction and the design of the network is in QuantumJS, but there's a link to the reality data via the Bentley solution. And in this case, users now in QGIS, but it could be an Esri or it could be a MicroStation, can now click on the map, they open the 360 picture, they open the mesh, they open the point cloud, and they can walk and run through it. And they're using their daily workflow linked to the digital context and linked to the reality data that you have. And it even goes further. It's about real integration. It's about doing your job. So what you want to see those results that you have created in your design. You want to see those results on top of your reality data. So you see with some functions, with some feature, you can just overlay here the underground cables on top of the point cloud, on top of the 360 picture, on top of the mesh. And then you can start doing decisions. Is that is that the right place? Maybe I need to change something. Maybe I can do a small measurement to see whether it would be useful to put the cable over there. And maybe I want to, that result that I'm now measuring, maybe I want to save and store that result into my design to use it then again in my workflow. So by these kind of integrations, you start using, and you're really doing your job, your daily job, where you use your reality data to make your decisions and make your analysis on your data. But also other tools, and maybe to end, it's a nice one to show. You want to collaborate, so you want to maybe say something to people on the field. Maybe you want to share something with the government. Hey, for instance, typically for these fiber projects, you need to place those cabinets. So by placing those, is that allowed to place it over there? So maybe you need to make a snapshot, put it in your documentation, and then maybe deliver that to the government to ask permission. So these kind of workflows, of course, helps to avoid sending people on the field and just making, with the experts, decisions by using your 4D digital context. So you see, you can put a snapshot and then you place it in your document, or maybe you can directly share, of course, this view with someone else, opening that in, I don't know, a MicroStation workflow. And that makes, of course, the working together and collaborating and using that digital context in an easy way. That is the professional way, and using reality so that you can benefit from data that you capture on the field. So I hope you enjoyed this webinar and learned a lot, and see some possibilities of the way that Bentley is covering and embracing the 4D digital context. So the way you can use all your reality data, all your hardware systems that you have, your drones and your handheld cameras that you use then to process a mesh, to process point clouds, use those point clouds and meshes to share and to analyze in a faster way. And then finally as well, being able to inside and outside your organization, bring that data, bring that reality data to your users. I guess that's key. It's giving your reality data and all the work that you're doing to update that information. It gives it a second use and a third use. I mean, a lot of people can benefit, and it does not have to be always the expert who analyze your data. It can be basic jazz users who maybe just need the view on the image, or just want to use a mesh, which is very easy to use and feels comfortable to be in 3D and check the data to do your daily job. So by this, I'm ending the presentation, referring to our website. If you want to have some more information, definitely go there. You'll find the products. You'll find the products, the combination, the reality modeling solution that we have that exists of the capture, analyze, share, and manage part. Of course, Pascal and myself are very happy to respond on any question that you have.
Great. Thank you so much both for the presentation. We definitely have some questions that have come in, and I know Pascal had answered them directly, but I do think it'll be a benefit for the audience to hear as well. So for the first question that came in, for city asset management, is there an automated system that identifies assets such as signs, streetscapes, features, etc.?
I think it's more a question for you, Lomme.
Yeah, it's definitely we have it. So I showed you there the automated detection on LiDAR. So we do have we call it a traffic sign detection, which uses the reflection, the intensity values of the LiDAR point cloud to detect the shape. It's built in a way that we of course want to get 100% success. So what you can also use if you're using, for instance, mobile mapping data, then you can also do and use the trajectory and the direction of your trajectory to make sure that you get better success. So there are different steps there. We definitely have a solution for that. It depends a bit on the data that you use. We even, of course, use AI and detect signs based on that, or a combination of both. Of course, the more you combine, the better your success. but that's definitely not a problem. So so happy to have a look in that. Of course, it depends a bit on which reality data you're using and you want to use, but I mean, based on that, we can start a discussion.
Great, thank you. Another question kind of along those lines is in regards to machine learning. And there's an understanding that you do use machine learning to analyze reality data. How does that work, and what are the deliverables produced by that process?
So the machine learning is applied in different steps. The first thing, it's mostly applied to photos, and but we also have machine learning algorithms working on point clouds, so more working on shapes, analyzing points and their properties. But for what regards the machine learning applied to photographs, then the users or we are labeling photos. This means that we are creating rectangles in photos where we detect specific objects. We do this at a scale of hundreds or thousands of different photos, and you submit this to our system, which is creating what we call a train detector. And the train detector is then applied to the 3D model and looking for those photos that we are using to create the mesh with photogrammetric algorithms, and then creating the bounding boxes around the object. So the first step is create labeled images library. Second step is to submit those photos, labeled images, to our service, which is creating train detectors, and the third step is to apply train detectors. We also have machine learning. So in this case, the deliverable is a bounding box, a set of different bounding boxes with a class. So every single bounding box is coming with a class saying inside this box, there's a gauge, there's a pump, there's a bus station, you know, whatever you may be detecting in photos that we can train machines to detect. And we also have some algorithms applied to point clouds on the side of the one that Loma just spoke about. We are having the capabilities to detect, to classify city-scale point clouds like high vegetation, low vegetation, rooftops, buildings, streets, cars. Everything can be automatically detected and segmented. So that's how we can apply machine learning to reality models.
Great, and that's kind of a good segue into this next question that came in regards to if the solution can automatically segment and classify point clouds, not by picture, but by points in the point clouds.
So I think that the question was related as well to objects. So Loma, and we'll let Loma speak more about this very specific topic, has demonstrated how this is applying to poles, for instance, or signs detection. But at the same time, we can work on point clouds, but detecting a pump made out of point clouds is more complex, because then you have to apply radically different algorithms that may be complex and not robust enough. So in this case, for small objects, I would say we prefer to use photos. For other types of objects like poles, I would let Loma speak on this.
Yeah, on segmenting that, that is part of the solution. So, for instance, that tree that I showed, if you click on a tree, we segment that tree at that point in time. At our solution, because I know that some software classifies on beforehand, that is not required in the Bentley solution. Classifying happens at the final stage. That means that if we, for instance, detect all the poles, is that we classify them as poles, so we segment them, but we do not do that on beforehand to then do the pole detection. So that's a little bit, it's the same for cables and all that information that you want to get. We just start from the entire point cloud and then do that process in the software. And this really relies on what you want to get, which object, but indeed it can, I guess what is crucial here to see is that it's what is good part of the Bentley solution is that you have and the image detection and the LiDAR detection. So you have a combination of both which means that sometimes you need to use both, sometimes you need to use one or the other. This is depending on what is the result that you want to achieve. But on the other hand, it's also relying on which data do you have, and is it city scale? Is it a inside-indoor project? That is all influencing which technique you will use, and that makes that. I guess it refers back to the title, embracing the 4D digital context. It makes the Bentley solution unique, that you can pick that one and just use it for your solution or for getting your results.
Great, thank you so much. A couple more questions here. Can you tell us a bit more about the way you deal with the 4D aspect of the reality data? So more specifically, how do you archive and reuse reality data captured over time?
Well, an important part, of course, of the 4D is that, I guess, that's all about managing your data. Of course, in the way you view and in the way you visualize your data and you analyze your data, that will be linked, of course, to kind of a time scale, and then you can pick that kind of time to see the data. But if we're talking about digital context, of course, that timing is essential, and then it all comes to managing your data, making sure that there's a person, there's a workflow behind that keeps track on at what time you capture your data, making sure that you can provide the updates, that you label your data, and that finally your users can benefit from seeing the most recent version, an updated version, the version at that time. So making sure that you keep track on that, and that's something we covered within our reality modeling solution, is that 4D aspect. And I think you cannot speak about the digital context if you don't think about that 4D. So think about that time. You need to make sure that you label that you think already about the future, because you will never create a reality mesh for a single point in time. You will do that with keeping an eye on what brings the future, and you need to update that, and you don't have to redo the entire project, of course. So you need to have a management tool to along your process. At all time you will use that. So it's, although maybe the part in the workflow that is not that attractive, but it's I guess the most essential part to have success of your digital context and finally using your digital twin.
Great, thank you. Can you just explain a bit more too, as well as the combined use of the mobile street view data and aerial imagery to create a more complete reality mesh? And secondly to that, does that mean that both data sets can be used at the same time?
That's a very good question, Leslie. Combining two heterogeneous data sets is a bit of a problem most of the time. You know, if we speak about cities, we use Kansas City, over 500 square kilometers, with hundreds of thousands of very high resolution photographs captured vertically and in oblique way, and that's a huge amount of data. On the other hand, you're having cars driving down the street and capturing point clouds by trillions, and 360-degree panoramas every 5 meters on hundreds of linear kilometers. So that's a huge amount of data. So the good news is both of those data sets are georeferenced. Both of those data sets are supposed to be seeing a big part of the city, in common. One is seeing it from the air, the other one is seeing it from the street level. But the bad news is they are coming at two different resolutions. From the car, you see a lot more details down the streets, and you capture them at different times because you're not flying and driving at the same time on the same day. So there's a lot of problems that need to be resolved, and so that's what we've been working on, and we've been developing processes over the years to handle that. So there's a way to manage aerial photographs on the one hand, manage ground imagery and point clouds and mobile mapping, on the other hand, and the acquisition of Orbit with Loma coming from this company is a huge move forwards as well, because that's really going together with creating the 4D digital context. We are talking about a 4D digital context. We're not talking about multiple 4D digital contexts. So you don't want to have multiple representations of your city. Eventually, you want to combine airborne imagery together with ground imagery and point clouds all together into one representation of your city that's automatically capturing the finest details depending on what's available in your reality data. So that's what we are doing. We have a complete workflow, complete solution that's aligning the two different data sets, taking the best of those different data sets and reality available, and creating this the finest possible model depending on the intervisibility between the object that captures the data and the actual scene.
Yeah, maybe I want to add here that by what we learned from the past is that when you're just capturing mobile mapping data for street view data, people were very happy about the result. Our customers were this accuracy was like, okay, it was top of the bill. It was perfectly aligned with what they were using. But then in a next project, they were capturing a reality mesh or an aerial lidar point cloud, and they were adding that other digital context to the street views, and then problems arise that you see that when you're measuring something in the one digital context, it's not the same as in the other digital context. And that's what we see in a lot of solutions these days. With the Bentley solution and with bringing that in one processing, we bring that together. And all the problems that you have with urban canyons, where you have shift or a drift of your GPS and not having any more the accuracy that you need, you can cover that. You can just make sure that it's all aligned on top of each other, and that's the beautiful thing about it.
Thank you so much. It's so great. Really, really very interesting stuff here. So we have time for just one more question, and then we'll close up the presentation for today. Last question coming in: can data from the field be provided for immediate processing? For example, a site visit that would need data processed and used while still present at the site.
So that has a lot to deal with, prediction speed, processing speed, and so on and so forth. So I would say yes, but that's a yes that I would say it depends. Okay, it depends on what you want to do. If you're capturing 10,000 photographs and you want them to be processed before you leave the field, you're going to have to stay on the field for a little bit longer, But we are developing a technology that's parallelizing the processing. So if you have the proper processing units at your disposal, this means if you are on site, for instance, with multiple PCs and you can connect those PCs and you can parallelize the processing, then you can make a very big model from a lot of photos since you are on the site before leaving it. But we have another technology that we've been developing over the last few years, which is leveraging the cloud processing. And we've been developing a very unique technology for cloud processing based on Microsoft Azure in cooperation with Microsoft. And we've been developing the first and only parallelization-enabled processing service for photogrammetry and point clouds. So you can put your point clouds, upload your photos in a project once you are in the field. And then once it is uploaded, of course, you need a proper connection to do that. But if it's for verification and so on, then we're talking about hundreds or a few thousands of photos, and that's still okay, or a few million points, and that's still working as well. But you're uploading this, and once it's in Azure, then we are having up to today that's 10 to 20 different what we call workers working on your project. This means they take a share of your processing and they do part of your job. Okay, and altogether, this is dividing the time by 10 or 20, depending on how many workers you'll get. And now we are working on the new technology that's leveraging the latest Azure improvements that would come almost without any limitation. This means we could put 200 workers on the same project. So that's taking cloud processing for a digital context creation to the next level. So I would say yes, depending on the size of your project, it's definitely feasible. A lot of our users do it in the mining, in telecom towers, in assets, modeling. Those guys do it once they are in the field for construction monitoring. They do this in the field. They submit the data to the cloud. They wait for the result. They get an email, click on the link, share it with the experts on the other side of the planet, and speak on the models before they leave the field. Because what's costing a lot to a company is to go back on site and multiple the on-site visits. So yes, the answer is yes, of course, to a certain extent. You don't kind of sit with an aircraft and wait for the model to be finished before you leave the city. Unless this is a very nice city.
Agreed. Well, great. Thank you so much. And with that, any other questions that we didn't get to today, we'll make sure we do get over to our presenters. So don't worry, we'll make sure that they get into the right hands. So thank you so much, Wilmot and Pascal, for your presentations today. And again, thank you all so much for attending. And thank you to Bentley for supporting this presentation. I do have a few final bits of business before we sign off. First, stay tuned for a follow-up thank you email after today's presentation. It'll also include the on-demand version of today's program. It'll be sent in about 3 days. We're always eager to receive your feedback, so certainly don't hesitate to not only reach out to us afterwards, but we do have a short survey that'll appear once you log out. As always, feel free to contact me directly. I'm on LinkedIn, but you can contact me here on via my email. I am working on several things right now, so if anybody has any questions on anything going on with not only spar3d.com and additional webinars that we're hosting, but everything that we are hosting for this year and moving into 2021. Lastly, thank you all again for taking the time to attend today's webinar. We appreciate your support and have a great rest of your day.
Thanks, everyone.